Any questions before I start this topic? This is not a very lengthy topic I have here. I mean, in fact, it's tough for me to cover in an hour the whole concept of performance tuning, but we'll be only looking at a surface of this concept. As far as I am concerned, performance tuning is an ocean. What makes someone good at performance tuning is constant application of various methodologies. There is no specific thing that you do these ABC steps and your system gets improved by X percentage of performance. No such thing as that, because what works in my environment might not work in your environment. Your environment, my environment are completely different, right? But what are we looking at it is how do we see the explain plan, pretty much some more little concepts on the performance tuning side. I like I said, performance tuning for me is a methodology. There are n number of things that we have to keep trying, right? One might work for my environment, the other might work for your environment. So there is no, like I said, there is no simple step-by-step approach, right? I mean, there is no simple blind steps that we follow and it improves the performance. I look at performance tuning in two different aspects. One is tuning from infra side. Second one is tuning from SQL side. When I say tuning from infra side, the major infrastructure items are CPU, memory, I/O, and network. Tuning of these items. How do you tune so that you use less CPU? Or how do you, or if you are like 8 CPU or 16 CPU system, sometimes increasing the CPU might be the only option. Increasing the memory. So how do you reduce I/O? These are the decisions you make at infrastructure level. Whereas on the other side, tuning from SQL side, it's a responsibility of both DBA and developer. This is the pure responsibility of a DBA. You might have to work with your storage team or a Unix team or whoever that is. Other thing is tuning from SQL side, which is responsibility of both DBA and developer. So the major activity in tuning from SQL side is tuning an SQL query. This is a major activity. And this is in fact majority of performance tuning person's job role too. Infrastructure side, nowadays our systems are like coming up with enough CPUs and memory. But at some point we have to say that, okay, this is the maximum cap we can invest. And on top of it, we have to start doing the SQL tuning. Now in SQL tuning area, the major thing like I wrote here is an SQL query, right? In SQL query, if you want to start tuning it, the first thing to look at is the execution plan or explain plan. Now, what is the path it is taking to run a query so that you can suggest some changes to a developer. Again, tuning an SQL query is not a prime responsibility of a DBA, but what happens is at the end of the day, it sits in our DBA queue for various reasons. Maybe a lack of skills at a developer side, or generally the industry expectation is a DBA has to solve these problems. But ideally, fixing an SQL query is not a responsibility of a DBA, but the more you help, it actually the better helps the business. So in that aspect, the first thing to look at in an SQL query is what is the path it is taking to execute. So that path you can find out by looking at the explain plan. Now, how do you get the explain plan of an SQL query in DB2? There are two ways. There are two ways. The first one is DB2 EXFMT, DB2 explain format. Here are the steps to generate an explain plan. So to show this in live, I'm creating some. You remember this example? This example we used in the admin move table concept. This is what I have to do. Set current explain mode to explain and run the query. This does not really run the query, but this will just show the explain plan. Now let me run these steps so that I will show you how does the explain output looks like. So the second way to look at is DB2 explain. So what I'm going to do is I'm going to create a customer table without index. I will show the cost, and then I will add an index, then I will show the cost. So I'm connecting to this test DB1 database. Drop table customer, drop sequence, user space, one index. Okay. So I'm creating a couple of table spaces. Then I'm creating a customer table, and I'm doing it in here. Just give me one quick second. I have just created that table with there are 1,000 records there. Now let me do this steps one after the another. I'm saying that db2 set current explain mode to explain. Then I'm running this. Here if you see it, when I set the explain mode to explain, when I run any select statement, it says that the required explain plan does not exist. What is this? Okay, I think I'm hitting an error here. Now let me see why I'm getting this error. Oh, okay. It requires some explain tables to be created. Right? What are the information it generates in intermediate for explain? It needs to be stored in some of the explain tables. Now let's see this. Let's try to understand what is this error. The explain tables must be created prior to invoking explain. So now I think somewhere I wrote it here. Yeah, this is where I have the explain tables. Now I need to go and run this explain.ddl. Let me go to this location, opt IBM db2 version. So this is these are the predefined tables. db2-tvsf explain.ddl. Right. This is how the tables I need to create. Now if I go back to the original location where I have so this is one time activity only. Now let me set this to explain, and if I run this, you see now I got a different error. The statement was not executed as only explain information requests are being processed. Now I'll just run this, but sdb1 hyphen output is customer dot out. So it asks certain questions and just press enter, and the respective previous SQL's information will see it in customer dot out. If I va customer dot out, this is where we will see the latest explain plan for the query. Okay, let me open one more time. At the starting, it is giving me the information of the version, then some database context, So the original statement, how DB2 converted this original statement to optimized statement. Is it doing any query rewriting? Then actually the access plan here. If you see here, the total cost is 68 units. So you can see it here how it actually executed the query. Customer table in a DB2 NST1 instance, it has 1000 records. Then these 1000 records are going through a table scan, right? The cost it needs is a 68.7097. That's what exactly we are seeing it here, right? Now what I'll be doing here is this is what we see here to 69, somewhere closer to that. Now what do we do is we'll go ahead and create an index on the customer ID column. Then we'll see how much is the cost right now. Let me go ahead and create index. And I'm running the statistics. Now I'm setting the explain mode. Running the same query. This time I say customer 2 dot out. If you open like customer 2 dot out, if you look at the major thing in an SQL query is a cost. So less cost means better execution, the faster execution. So you see here the previous one is like 68 units, now it is a 30 units, and you see this index scan here. So more detailed information at the bottom, how it is actually doing index scan and what it is doing and all that information. But less cost means the better execution plan. So this information, if you are not comfortable in tuning, you can share it with the developer. It's a major developer's responsibility to optimize the query. So how do you get this uh, scan information? I mean the access path information using the first option we looked at, which is DB2 explain format. But the thing here is you have to create some explain tables. But sometimes you might not be interested in doing all that. That's where you have another option called DB2 explain. In DB2 explain, it's a quick method of getting explain plan. You don't require to populate tables like running this explain.ddl and create those tables. It's pretty much straightforward. You say the DB2 explain the current database name. What is the statement for which you want explain plan to be generated? Whatever you see, the access path pretty much it defines on the screen. it's a test db1. You pretty much see here the same class too. So these are the two different ways where you can pull up the information. So there is one more command which actually complements these two, is Db2 Advisor. Sometimes as a DBA you must recommend some improvements to an SQL query. But what if you are not a guy for SQL tuning, right? So that's where we have a command called Db2 Advisor. So what Db2 Advisor does is it helps the users on creation of, do we want to create any materialized query tables or any new indexes? Should I repartition of multi-dimensional clustering tables, which is a concept in DPF? It's only licensed in data partitioning features, and any deletion of unused objects. These recommendations, it's like if you're familiar with Oracle, it's a SQL tuning advisor, right? To help us get these recommendations, so I'm creating a student. I have a student table here. So I have like 0.7 million records in a student table. I'm asking the DB2 advisor that when I'm running the select count of SID from a student, you see in the section that it gives list of recommended indexes, it is saying that okay, it's better you create this index. The index size it occupies is 5 MB. Now let me create this student table and insert the data and show you the output of DB2 advisor. This is a very useful tool as far as I am concerned, because this is the facility of a DBA where the system will tell you, when you have a huge query, when you have no clue what to do, you just have to stay on top of a developer, means you have to run this and tell them that okay, this is what my suggestions are, the system is advising. Now let me create a table student. Hopefully it's not running out of log space now. Okay. We have 1 million records here. So what I'm saying here is suddenly user came and telling you that when I'm running this count star, it's taking maybe a number of seconds or minutes. Is there any way to optimize it? Okay. That's where you can take help from this Db2 Advisor. Zero solutions evaluated. No indexes recommended. Why? Maybe there is no best way. Now let me say where SID equal to 501.
Yeah, maybe because
Full complete full
you
table.
don't have unique indexes. Yeah.
Okay. So when I say this count star, it's like getting entire table. So there is no best suggestion. Whereas when I run this with the SID equal to 501, let me redirect this to some file. Okay. Here I see one of the suggestion has create index on SID. Execution started, recommending indexes, total disk space needed, list of recommended indexes, unused indexes. Yep, that's not bad. So I should change this here then. Okay, so a quick tool, even how big your SQL can be, it says that okay, these might help you. Pretty much, it's major helpful from the index point of view.
Ravi, for example, how to check uh, how many indexes are there on a particular table? How to evaluate that information?
There are metadata tables. You can query that.
Okay.
One
Okay.
second. Or you can do the DB2 PD. Yesterday I was showing you that index information. TCB stats, -TCB stats index. Or you can get that from, let me show you that. I should give a table name here. Or you can query the sys indexes table. Okay, let's log in. Yes, this is the table. Syscat.indexes. Syscat is one of the metadata schema, right? If you look at, there is a table name, there is an index name. Select count start from syscat.indexes, where tab name is equal to student. The rest, I think it's easy for you. There are no indexes on the student table. If I create index adx1 underscore test on, you see there is a count increased to 1 right now. So we can get the information, rest of the information from here. Or sometimes the easiest way is, yesterday Vasu was talking about Data Studio, right? There is a tool. You can extract the DDLs from there. Like SQL Developer, Oracle has a SQL Developer. Right. The similar way. Is this what?
Okay.
Yeah, that's the easiest way actually.
Okay.
So what are we looking at right now? We looked at 3 different commands: explain format, explain, Db2 Advisor. Okay. So are there any some of the proactive ways that I can identify a performance problem? Okay. Here are few slides, very few slides that talks about them. For example, we know a concept of snapshot, right? They keep saying that taking the snapshot goes away from our DB2 database, but it's not going anywhere. We know it's a deprecated, but it's not getting away. It's a DB2 get snapshot for database on sample. If you see here, rows selected is 89,000. Actually, rows read, this is at entire database level, and rows read is 502 million. So what this indicates at a high level in a database is we are having many number of full table scans. We are having many number of full table scans. Now, how you can see that information? If you have some kind of an information like this, how you see which table is having more number of full table scans or which table needs an index? This information can help you. Yesterday we learned about DB2 PD. If you do -TCB stats, that is table level statistics for all tables, right? Okay, let me here give the student table. No, it's not giving me that what I want. Okay. Hyphen TCB stats all. So you look at some of the arrows here, I'll explain you. There is a table called invent, which actually went through 85,634 scans. Invent table has many table scans with a large number of read rows and often and very often, very rarely the index scans. Now, how we are saying that against the TCB table stats for invent table, we are having 85,634 scans. Now, when I say it is having their scans, are they index scans or are they full table scans? Any one of it can it be, right? It can be a table level scan or it can be an index level scan. Now then go ahead and look at invent tables indexes. If you look at here invent table, there is an index ID against the index statistics, index ID 1 and index ID 2. It has two indexes because I see only two records here, two rows here. But look at this scans it had against each index. Index 1 had only one scan and index 2 had 0 scans. What that tells us? So it's not having index level scans. So all these scans must be a full table scans. Through these many scans, it had these many reads. Now majority of the reads are happening through a non-index way. That is a table scan level. Also, we can quickly notify. You can quickly note here that organization table had significant number of inserts. Please note that this information is only from the previous database start time. If my database is deactivated and activated again, all this information is gone, right? So that's why it's important to keep your database activated even though there is no connection, right? It can only pull the information from memory. Okay. Now you pinpointed a problem here. At a high level using a snapshot, we learned that I have a read problem on my system. Number of selection rows per number of reads actually I do is very less. So that's because not just in DB2, any database, that is because of full table scans we do. Now which tables we are doing a hefty full table scans? This command will give us that information and you can see it from the index level here. Now how do I solve this problem? To solve this problem on creating a right index, you need to find out what are all the queries that are coming on invent table. So that is where you can again get a snapshot for all dynamic SQLs. So you will get a quick text output, and in a text output, if you can search for it, you can see. If you can search for a word called invent, then you can see something like this. You can see all the queries that are coming up on invent table. So get snapshot for dynamic SQL on sample. This dynamic SQL will flush everything out of memory to a file on the screen. What are the current SQLs which are in memory? Because DB2 PD also gets you the information from memory. Now this is another way. You describe indexes for table, show detail. Instead of you querying the indexes table, scat.indexes, let me run this once. We say here connect to test, describe table student, right? Describe table student, describe indexes for student, show detail. Well, this is a little scary that you're getting there is one record selected and this is index. But unfortunately, there is no concept like column or set lines like we have it in SQL Plus. No, you cannot do that here. Right. So what we are seeing it here is we are only seeing that there is an index on name, but even though ID select is executed like number of times, there is no index. So it is worth creating an index on this. Right. This is all a proactive approach. The reactive approach, like we have discussed, Db2 Advisor. So if you want to solve the problem proactively, just see where the indexes can help. So that's the same thing. You can repeat it here with the help of explain. So you can create quickly an index on ID and you can compare the costs here. So without creation of an index, the query is taking 91 units, which is going for table scans. But here it is actually taking only 7. Right. So here are the steps that if you want to see proactive creation of indexes, generate snapshot on a table. It's not at a table, just at an entire database level. Monitor for check for tables with maximum scans, then create indexes. Or most of the time, this is a very rare thing that people have a time and do this kind of stuff, right? But it's up to you, depends on it. So it's better to have